Howdy, AP PreCal. It is Miss Kosh. I wanted to talk you through this Desmos thing I made, and I'll put the link to it in the description of this video. But it's really helpful when they start asking questions about what's the theta value for this part of the curve? And they like to ask that type of question a lot. So what I did is I took the same equation and I have it going from, I don't know if you can, okay, so I have these two equations. It's the exact same thing, but one of them goes from 0 to A, one of them goes from 0 to B. And then when you look at those sliders, that's the word I was looking for, one of them goes from 0 to 1 pi, and the other goes from 0 to 2 pi, okay? And so we can look and see, does this do everything, let me see if I can scale, oh, well, I'm trying to scale this. There we go. Does this do everything we need to do by pi, or do we need to go to 2 pi? So if I turn on this first cardioid and I hit play, you'll notice that if I only allow it to go to pi, I only get half of a cardioid. Okay, and then it starts undoing what it's been doing. Okay, so that one moved kind of slowly. On this one, when I go from 0 to 2 pi, it's made it here by about pi, and then it keeps going, and it makes it back to where it began by 2 pi. Okay, I could come into this equation, and I could change this to, oh, interesting. I could change this to sine to remind myself what a cardioid looks like if I'm going, if I have sine in my equation versus cosine. Okay, so you could play with that, but notice you can plug in different values to see, okay, where am I? What's the order? What's the pattern? What's the right word? What's the path I'm tracing out as theta goes from 0 to 2 pi? Okay, now I have two equations with a limacon. Same idea. I have these sliders. One of them goes from 0 to pi, the other 0 to 2 pi. So let's turn on this first graph here, and then when I hit play, the limacon, we don't get the inner loop. Well, we don't get more than the inner loop. We just go from 0 to pi right there, which is interesting, but you know, whatever. And then the other one, if I go to 2 pi now, then watch the process of that. Okay, we were talking today in class about, it did the right-hand side. I don't have a good way to show you what I'm talking about, but the right-hand side of this curve comes first because those are the values it returned to, well, what we looked at. This was the equation 2 plus 4 sine theta. If I go to Desmos, sorry, I wasn't thinking I would do this, but it might be helpful. If I graph this as a rectangular equation, y equals 2 plus 4 cosine theta, well, x, okay, I have zeros here and x and y intercepts. So what it's doing is we have from 2 pi over 3 to pi, we have negative values that are getting more negative. So from 2 pi over 3, we were back at 0 there at the pole. So we had traced this out. Let's see if I can show you. We had started here. We get to, oh no, 2 pi over 3 doesn't make sense. Oh, you know what? Did I type in the wrong equation? I sure did. I was like, why is this not matching what I expected to see? Because I did cosine when I should have done sine. My apologies. Did you catch that before I did? If so, you're very smart. Okay, so what do we care about? Here's another, well, the 0 there, well, the midpoint there, but whatever. Okay, so from 7 pi over 6 to 3 pi over 2, we have negative values. So we're tracing this out. 7 pi over 6 is where we hit 0 right about here. And then from 7 pi over 6 to 3 pi over 2 about here, we should be 7 pi over 6 to 3 pi over 2 is in quadrant 3. However, our R values were negative. And so, oops, right here. So a negative, if we were in quadrant 3, but we have a negative radius, we end up in quadrant 1, which is why we get the right-hand side of that inner loop. Well, that's what we were talking about in class Friday and today. Okay, so then we finish this up, and it follows that path. So I think it's very helpful to trace that out, and we can kind of see what's happening. And then I did a rose with an even number of petals. Notice, instead of 1, I don't know. As we get started here, it comes out and around, and so it's doing quadrant 1 first, then quadrant 4, but it stops at that point by pi. So the even rows, and we can check, okay, let's see, let's change this to a different even rows. On this one, if it has sine of 4 theta, that should give us 8 petals, but I only see 1, 2, 3, 4 petals by that time. So let's see what happens if I change this to 6. I should get 12 petals, but by pi, I only have 1, 2, 3, 4, 5, 6. Okay, so you may notice that an even number of petals, pi is not sufficient. So what we need to do is we need to go to 2 pi. And we'll notice this follows the pattern of quadrant 1, quadrant 4, quadrant 3, quadrant 2. Okay, how do we know that? 1, we could practice it enough and just kind of know it. Or 2, we plug in values and we can see that we get, okay, so like when we're looking at this quadrant, what do I want? Right here. When we're looking at this quadrant 4 stuff, what we were actually plugging in were values from quadrant 2, but they gave us a negative radius. So then that moves us into quadrant 4 next. Okay, so plug in points in practice. Same idea here. If I have, okay, I'm struggling. Oh, okay, let's do this. There we go, sorry. If I had 4, it gives us 8 petals. If I have 6, it gives me 12 petals. If I have 8, it should give me 16 petals. That's very fun. Okay. However, the cool thing, so now if I have an odd number of petals, check this out. When I hit play, this does the whole thing. It graphs everything we need by pi. And notice the process that it's going. Okay, I'm here, so if I turn that one off and I want to do the one from, we were talking about it in class, why does this just seem to be stopping? Well, it's retracing its steps, and we can't quite see that. So if we allow that to go from 0 to 2 pi, we're doing everything we did by pi, and then we're doing it again, right on top of what we already saw, if that makes sense. And there it goes. So that one, we could come along and say, what happens if I make this 5? I should have 5 petals. If I make this a 7, I should have 7 petals. And we can follow this process. Okay. Woo, that was quick. You know what, we should have, yeah, and then it stops because it did it all by pi. So, interesting things to know, and they do like to ask questions about this from what I can tell. So, good luck. Go practice. You're welcome to play with this, to change different components of that, to change the equations, to change the values across the bottom so you can see what happens. All right, like, subscribe, comment, and go practice. Good luck.